Glaciers and ice sheets. About 10% of Earth's surface is covered by ice. In the form of glaciers, ice can carve out valleys and carry the debris hundreds of miles. Although ice once covered huge areas of our planet, today it has retreated toward the poles and the highest mountain areas. However, the landscape it carved remains. Although ice is a solid under pressure, it can flow in the same way that rocks flow in Earth's mantle. The structure is very similar. As snow compacts, air is squeezed out and the white, crumbly snow changes into a blue crystalline substance containing ice crystals rather than minerals. The crystals are lubricated by a microscopic film of water, kept liquid by dissolved salts. The ice can literally transform the landscape. Moving across the land, ice occupies more volume than water. As water seeps into crevices and freezes, it shatters rocks and boulders. Meanwhile, the snow around the mountains blankets the ground, triggering avalanches or packing into ice. Eventually, this ice begins to move. In extremely cold regions, the ice covers the landscape in a sheet that may be thousands of feet thick. Within it, there may be fast-flowing streams of ice caused by the ground beneath, falling away, being lubricated by mud, or even being warmed by volcanic activity, as in part of Antarctica. As the ice sheet thins, it can part around rocky peaks or nunataks to form valley glaciers and then reunite with the other side in what are called Piedmont glaciers. The flow rate of a glacier can be very slow, between a few yards and a few hundred yards each year. To maintain the same flow as even a small mountain stream, a glacier has to fill the whole valley. As the glacier moves, it grinds small rocks into powder. Embedded boulders leave deep marks called striations in the sides of the U-shaped valleys. In some glacial valleys, the ice cuts deep into the ground below, leaving lakes when the ice retreats. As the ice progresses, a thick layer of fine clay builds up underneath the glacier. The pressure may be enough to keep water liquid here, lubricating the base of the glacier and leaving oval mounds of clay known as drumlins. As the snout of the glacier, the rest of the sediment and rock is deposited as a terminal moraine. Often a block of ice is left behind. This will melt and form a deep pond or kettle. Ice ages. Geologists are uncertain as to what causes an ice age. However, the long-term cycles in the inclination of Earth's axis, called the Milankovitch cycles, appear to be involved. Fluctuations in the levels of atmospheric carbon dioxide may also play a role. But once the ice starts to advance, the change is rapid. White ice and snow reflect more of the sun's radiation back into space, and the planet cools further. Scientists have worked out that global temperatures appear to fluctuate between two relatively stable states. This has occurred about 35 times in Earth's history. The first clear evidence of an ice age comes from the Huronian period, dating back roughly 2.4 billion years. The most recent ice age began about 2 million years ago. This may still be in progress, despite the present mild climate. Until about 14,000 years ago, there was a huge amount of ice locked up in the polar ice caps, and sea levels were about 260 feet lower than present-day levels. But the ice also depressed the land, which is still slowly rising in northern latitudes. A plot of the average worldwide temperatures in July over the past 200,000 years show that it is particularly warm at the present time. Lakes sometimes form in six or steep-sided basins made by glaciers. Masses of moving ice called glaciers leave characteristic U-shaped valleys in their path. These are very different from V-shaped river valleys. This valley in Switzerland was V-shaped until the last ice age, when a glacier deepened it into a U-shaped valley. Cool. As snout of glacier melts, some rock debris forms ridge known as a terminal moraine. An aerial view shows the large Kahiltna Glacier in Alaska. Human activities have greatly contributed to a phenomenon called global warming that has caused many glaciers around the world to shrink. If the Kahiltna Glacier melted, it would reveal a deep U-shaped valley that it has gouged in the mountain beneath. Most of Antarctica is covered by a thick ice sheet. The ice flows from regions of high snowfall in the center of the continent, streaming out toward the coast. In the winter, the sheet extends into the sea. Some thick ice shelves remain all year round, occasionally releasing enormous icebergs. In recent years, global warming has caused large sections of the ice shelves to break off, raising global sea levels. These giant icebergs have broken away from the ice sheets of Antarctica and clearly show the effects of waves undercutting their edges. About 90% of icebergs' volume is invisible beneath the water, which means that they can be extremely dangerous to passing ships. Icebergs can carry clay and rock that is gouged from the land far out to sea or is found in ocean sediments.